Hey guys, this is Advent of Code day number 4. So let's get started. Looks like the chief's not here. Next one of the historians pulls out a device and pushes the only button on it. After a brief flash, he recognized the interior of the Ceres monitoring station. As the search for the chief continues, a small elf who lives on the station tugs on your shirt. She'd like to know if you could help her with her word search. She only has to find one word: Christmas. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. It's a little unusual though, as you don't merely need to find one instance of Christmas, you need to find all of them. Here are a few ways Christmas might appear where irrelevant characters have been replaced with the. The actual word search will be full of letters instead. Okay. Alright guys, so let's get started. I was gonna do this in Python guys, but it's gonna be too easy, so I'm gonna do it in C. So guys, I'm gonna create a small function in the string library that I created yesterday for day 3. And it's gonna allow us to like check if a string is equal in both reverse order and the regular order that a string is spelled. So I'm gonna open up stringlist.h. I'm gonna let this be a boolean. I'm gonna call it string reverse match. And it's gonna take in a const-char pointer to a string, and a const-char pointer reversed str or reversed string. So let's me implement this guys. So here's how the string reverse match function will work guys. So let's say we call string let's say this is our string. So our string is hello exclamation mark, and then our reversed string is O exclamation OLLEH. Then we call string reverse match on the string, and then we call pass in the reverse string as a parameter. When we do this guys, it should output true, because whenever you reverse this string, whenever you reverse this reverse string, it equals to hello. And also guys, I'm thinking if we do something like this, let's say the reversed string is equal to the string, then the string reverse match function should return something like this. So it should return something like should return true. And if we do something like this guys, like the Xmas thing, and we let the reversed string equal to SMAX, and we call string reverse match string reversed string. We should get true. No, this should be SAMX. We should get true. But if we do pass something like this, like XMS, then we say reversed string SMAX. Whenever we reverse this, guys, this reverse string, it will give us like XAMS, and this is not equal to this string, guys, so therefore this should give us false. And let's say the string was the other way around, guys, like SMAX, and then we say our reverse string is XMS. Then we call string reverse match string reversed string. This should let's say this is SAMX, right? And this should give us true, guys, because if we reverse this string right here, it should be equal to this reverse string. So let's implement this function now, guys. So if let me see something. I'm thinking about how I would do this, guys. So if I say S, compare that with this. Alright, guys, so here's how I'm gonna implement this function. So I'm gonna check to see if the length of the string, before I actually do that, I'm gonna say size t length 1 equals to the length of string, and length 2 equals to the length of reversed string. And if length 1 is not equal to length 2, then return false. I'm gonna say for each element in the string, and we're gonna have a size t of counts, guys. So we're gonna have one for reverse match count. We're gonna set that to 0, and we're gonna have one for regular match count, set that to 0. And then, guys, we're gonna say if string at index I is equal to so we're handling like this condition now, guys, like if both strings are equal. So if string at index I is equal to reverse string at index I, then regular match count plus equal, yeah, just plus plus. Then guys, we can say if string at index I is equal to reverse string at index I. So we're gonna say reverse string, which is gonna be the length minus I plus 1. Then we're gonna say reverse match count. We're gonna increment that. We're gonna say if string at index I, guys, at index length minus I plus 1, guys. So this way we're checking like the reverse count in both ways. Reverse to match count, let's call it this. So if it's equal to reversed string index I, guys, then I'm gonna say reverse to match count plus plus. Then I'm gonna say if, after we exit this loop, guys, that validates to see if everything is equal, we can say if regular match count is equal to length 1, then return true, and we can do it for the rest of them as well. If reverse match count is equal to length 1, return true. Wait, but actually, guys, couldn't we do something like this? Because if, let's say we get a length of 4 for one of them, and it should be equal to like 9, and then we get 6 for one of them, and then we check if it's equal to 9, we get false. We do the last one and we get 9 equals 9, we get true. So guys, we can just do something like this. At the end we can say return regular match count is equal to length 1 ORed by reverse match count ORed by is equal to length 1 ORed by reverse match count is equal to length 1 again. Then now, guys, we can just test out our function. So I'm gonna go into day 4. I'm gonna get our example input, place it in example and .txt. Then guys, I'm gonna puzzle input. Oh shoot, I wrote it to the wrong file. Let's open puzzle.txt and let's open example.txt. Let's copy this again. Alright guys, so now that we have done that, we can create a solve.c. Can include the basic libraries we're going to include, or library that we created. And then now guys, we can say, let's make string equal to xmass and reverse string equal to reverse string equal to samx. Then we just call printf modulus s is equal to modulus s. And then we just say string reversed string. Then we call string reverse match string reversed string. Return true, return false, and let's go into day 4 guys. Let's run our code. Have an error. Oh, I see. This should be string length. This should be reverse match count. And this should be a pointer. And let's run our code. So we get true, guys, for that one. And let's test it out with a different thing. Wait, let's have an array of reversed strings. So we're gonna have like hello. Gonna have like the actual reverse version of hello. We're gonna have xmass. We're gonna have that guys. We're gonna have a random thing. let's have some strings. So we're gonna have hello for the first thing. We're gonna have hello right here again. Gonna have X. Now we're gonna test this out, guys. Alright guys, now let's run the code again. Alright, so this is correct. This is also correct. This is also correct. What if I change it to something like should get false somewhere. Nice, so it's working, guys. So now that we have that function, we can actually start writing code to solve this word search thing. So we're gonna implement a basic thing to read each lines in the file, guys, because if we look at the example txt, we're gonna read everything line by line. So we're gonna say file pointer f equals fopen example txt in read mode. I'm gonna close the file, and guys, I'm gonna say char c equals to null. We're gonna say while c is equal to f get c f, and it's not equal to the end of the file. I'm gonna say if c is equal to a new line character, guys, then wait, let's create a function called stringlist. It's gonna be of type stringlist, and we're gonna say we're just gonna say file underscore read lines, file pointer f. So we're gonna say char c equal to null right here. We're gonna say while c is equal to f get c, f is not equal to EOF. We're gonna declare string list t of lines right up here, and we're gonna return our lines in a list, guys. We're gonna have a buffer. Guys, we're gonna have a buffer, and we're gonna call string append char from our library that we implemented. We're gonna have a size t buffer length. Let's set that to 0. C, and we're gonna check if C is equal to a new line, then string underscore list append. We're gonna append our buffer, guys, so we're gonna say ampersand lines, then our buffer, then we can just say continue, but we're gonna need to free our buffer right here, and then set the buff length equal to 0. Pass in the buff length right here, guys, and then at the end, once we reach the end of the file, guys, we can just say if buff length just set buff equal null. So we can say, guys, if not buff or buff underscore length, if buff, we can just say if buff, then string append list lines buffer. We pass in our buffer, guys. And then now, guys, we can just call this function so we can say char pointer line, no, we can say string underscore list t lines equal find read line lines, then we pass in our file stream, then we call string print string list underscore print lines, just to get a visual output of what our string list looks like. Then we can destroy it when we're finished with it, guys. Oh, this should be string list underscore append. So oh, I see the issue, guys, so I forgot to wrap this in parentheses. So now, guys, you can see we're actually parsing the file example.txt, so it essentially splits each new line and places it into an array-like structure. Now, guys, we could try to print it each lines like this. the same thing, guys. So now we need to implement an algorithm to actually search this puzzle. So I'm gonna create a boolean, a function called let me see. Let's call it void find um count xmas, and it's gonna accept a string list t of lines, guys. Let's call it find underscore xmas frequency. So we're gonna call find xmas frequency. I'm passing the lines, guys. So here's how we're gonna do this, guys. We're gonna iterate through each lines like this. We're gonna create a function called bool find xmas underscore vertical, and it's gonna take in a string list t lines. It's gonna take in the current position we are at. Wait, let's just call it row. And it's gonna take in column as well, guys. And we're gonna say we're gonna have a buffer, guys. It's gonna be equal to the length of xmas, so, or Christmas, so 1, 2, so it's 1, 2, 3, 4. So I'm gonna let this be a buffer of 5 bytes. Then we're gonna say xmas string equals to xmas. We're gonna iterate through each. No, we're gonna iterate through each character, through each rows, guys. So we're gonna say if for size t, I is equal to 0, I is less than we're gonna get the current length. is gonna be equal to the column and it's gonna be lines dot count I plus plus. I is gonna be less than 4, guys. Wait. We know that the length of Xmas is 4, so we're gonna iterate from 0 going up to 4 there. So I is less than 4. We're gonna say if lines at index, if lines dot strings so we're gonna say row at index column at index row I wonder if oh, so everything is the same dimensions. So this is like a matrix problem, guys. So if lines dot strings at the current column at index row is equal to Xmas. Let's actually define Xmas string up here, guys. So Xmas and then we're gonna define Xmas length. Let's let it be 4. Xmas length. Plus 1. And then we're gonna say Xmas underscore string at index I, guys. We're gonna say if col we're gonna say if column, guys, plus I is greater than lines dot count, then return false, guys. Otherwise, we're just gonna say column plus plus wait, if this is equal to false, then we can just return false, guys. Otherwise, we just increment the column. Then now, guys, we can have a count. So let's call it let's make this a int total frequency equals to 0, total frequency we're gonna say if find xms underscore vertical lines at index I with the column let's call this line length is equal to the string length of lines at index I. The column is gonna be I. We're gonna let this be something like this for size t. I is equal 0, I is less than the line length. No, j is equal to 0. J is less than the line length. And we just increment j, guys, when we say if find xms vertical index j, which is going to be the row, and I, which is going to be the column, then total frequency plus equal to, you know what, let's have a vertical frequency right here. And vertical frequency plus equal, just plus right here. And we could just let this be plus. And at the end we could just say there are multi vertical frequencies of in the puzzle. Print out the vertical frequency. And let's try to compile and see if the vertical thing is working, guys. This should be lines.count. Should be lines.strings. Let's run. There are one vertical frequency. Wait, this should be there is one vertical and is this true? So we go down xmas Oh, so guys, because we want to like check in both reverse order, what I'm gonna do is say buffer at index I is gonna be equal to lines dot, it's just gonna be equal to, wait, this should be return false. So we're just gonna say buffer at index I, guys, is equal to xmass underscore string at index I. No, this should be lines dot strings column and row, guys, and then at the end of our program, guys, at the end of this function, we can just say return string reverse match, and then we pass in our buffer, and then because this could be reversed, it doesn't matter, we could just say xmass underscore string and then our buffer, guys. Then we can just run or solve. So our function is actually working as expected, but we also, so after each one of these, guys, wait, let's print out modulus s, and then xmass. There's actually two of them, SAMX. SAMX. So this is 1. There's 2 occurrences, but it's given 1. Hmm. Oh. Hmm. Wait, we shouldn't do this, guys. We should actually do this. Buff index I. Yeah, because we can't validate it. And now we should get a vertical count of 2. Alright. Okay, this looks good. So then now, guys, I'm gonna implement the diagonal, not the diagonal version as yet. I'm gonna create a version of, so I'm gonna implement find xmas in order to find that word horizontally. Horizontal string list t lines. We're gonna have a buffer again. And we're just gonna stay in the same column, guys, and we're gonna say if we're gonna get the length of the current line we're at, or the current column we're at. So we're gonna say size t line length equals to the string length of lines.strings at index column. We're gonna say if line length if I if row plus column is greater than or equal to line length, then we can just return false. Otherwise, we can say buff at index I equals line dot strings index column and then this should be row plus I. Then now guys, at the end we can say return string reverse match xmas string buffer. Then we can say horizontal frequency, set that to 0. So then now guys, I can say the horizontal frequency of the word in the puzzle is and I can call this function guys, I say find xmas horizontal lines ji. So let's see what we get now guys. So we get a frequency of 4. Is that correct? Yes, this is correct. This is 1 right here. This is 2. This is 3. This is 4. Wait, 1. Then 2. Then 3. 5. It's supposed to give me 5. Alright, for now guys, I'm gonna try to work on diagonal, let's do left diagonal. So for the left diagonal, I'm gonna say for size t, I is equal to 0, I is less than, you're gonna have to buffer. Wait, I'm doing, If row should be col, so I'm gonna say if column is less than lines, if column plus I is greater than lines, then are equal to lines.count, then return false. Otherwise, I'm gonna say I'm gonna say column plus I, so buff index I equals to lines.strings index column plus I, so it's gonna be col plus I index row plus I, and I'm gonna say if lines lines.strings at index I row plus I is greater than or equal to line length, then return false, otherwise we just say plus I. So it's gonna be like boom, boom. So it's gonna be like 0, 0, then 1, 1, 2, 2. Alright, so let me try to test out. diagonal frequency is 49. Oh, I see, guys. I forgot to do. So now I get 11. Now let's do the right diagonal. So right to left. Let's think about how we're gonna do that. We could probably do something like column minus I. So let's say we're at 0. Would get at the first iteration we'll get column minus 0. We'll get back 0. If we're at so col minus I. Wait, this should actually be column. No wonder why I'm getting So call minus I. Wait, let me run this code for a second before. So I got 5, now I get... Okay. Wait, let me look at the horizontal, cause I'm supposed to get like 5, I think, for the horizontal, cause this is 1 right here. This is 2. This is 3. This is supposed to be 4. This is supposed to be 5. Let me call. So vertically we're supposed to get 3, is that correct? Yeah, this is 1 right here. And this is 1 right here. It's supposed to be 2, I guess. We'll find out. Let's try to implement this right diagonal thing. So let's implement this. So how are we gonna implement this, guys? I could actually invert this a bit. So buff, we could just say buff to index I. Could do this too. Wait, if call, hmm, oh, I could actually say size t, since this is a size t and this is c, size t, difference, call plus I. Alright, if call plus I is less than lines.count, then wait, return false, because if we're going from right, we're actually increasing the column, but we're decreasing the row. wait, hold on guys. So, if I'm at index 0, I'm at row number 1, let's say I'm at row number 2 actually. So 2 plus 0 would give us 2. And if we subtract the row, from here we would get 0. So if we have something like 2, so then now when this is 1, it's going to be 2 plus 1, you're going to get 3 minus row gonna get 1 minus the row so then the row plus would give us the row and then 0 give us 1 just subtract that, we're gonna get row minus 1 equals 0 1 0. So this formula should work guys. So row, it's gonna be row plus I and then minus the row and then the row minus So I get 17 now, guys. Now I need to figure out what's causing. Oh, we could optimize right here a bit, so we say if rho plus I is greater than or equal to line length, return false. I need to figure out why this horizontal thing is not working. Wait, I'm doing rho plus col? This should be rho plus I. So now I get 18. Now guys, I'm gonna try it on the puzzle txt. I get this value, is this correct? Yup, it is correct, guys. So now let's go to part 2. The elf looks quizzically at you. Did you understand the assignment? Looking for instructions, you flip over the word, search to find that this isn't actually an Xmas puzzle. It's an X-mess puzzle, in which you're supposed to find two mess in the shape of an X. One way to achieve that is like this. Oh, so the shape of an X.